going to also be easily compared to that as well, all right, structure-wise. All right, one more and then we'll move on to something new. Okay, I3 minus. Okay, so the first thing we want to do is valence shell electrons. How many valence shell electrons does iodine have? 7. And there's 3 of them, so that's 21 for a total of 21 electrons. But wait, there's an overall negative charge, so that's 1 more electron, right? So that's 22 total electrons that have to be placed. So which one of the I's is your central atom? That was supposed to be a joke. It's not as funny as if I had to explain it, right? How about let's just pick one of them? All right, so now what do we do? Okay, so there's our skeleton. Iodine's going to be the central atom. We have no other choice here, okay? So then what do? We've taken care of 2 4 electrons. So where do the rest of them go? In pairs around the terminal iodines to satisfy the octet. So that's 2, 4, 6, 8. 2, 4, 6, 8. Okay, so now by doing that, we've taken care of 2, 4, 6, 8, 10, 12, 14, 16 of the 22 electrons. Where do the leftover electrons go? On the central atom as lone pairs. So 16, 17, 18, 19, 20, 21, 22. Okay? Two, 4, 6, 8 around the terminal iodine. 2, 4, 6, 8 around the terminal iodine. 2, 4, 6, 8, 10 around the central iodine. Are we okay with that? Where is iodine on the periodic chart? It's group 7, right? What period? Period 5. Remember, anything in period 3 or higher can have more than 8 electrons around it. Where it would like to satisfy the octet, it's okay to have more than the octet. All right, so that would be a valid structure for the triiodide ion. Okay? Now, this bracket here with an overall negative sign is just letting you know that that structure or that polyatomic ion has an extra electron on it. Okay, because as you well know, if I drew it like that, that doesn't have 22 electrons. That only has 21. Okay, so you have to show that you have an overall negative charge there. Show that extra electron. Okay? Is that good? Comfortable? Have you had a chance to practice some of them over the long break? Okay, so I don't know when your next test is, so you'll probably need to practice obviously before then if you want to get proficient at it. Okay? All right, so now what I'd like to do is maybe go back to, we're going to go back to chapter 6 and we're going to concentrate on learning how to name some of these structures. So far, you've been putting things together now, all right? Taking the atoms, you know that you've got protons, electrons, and neutrons, right? You know that you can put these atoms together and make molecules. So now what we're going to do is learn how to name all these things, okay? So in naming them, there are 2 main types of compounds that we're interested in naming. The first are ionic compounds. And then the others are covalent compounds. Okay. Do you recall what an ionic compound is? Now, here's where I'm at a disadvantage. I don't know what you've done this term. So if you don't know, you just have to let me know and we can explain it, because I don't know what y'all have covered. Have y'all talked about ionic compounds?
It's just the strongest bond.
Okay. All right. So an ionic compound, as the word might suggest, is a compound between ions. Ionic compound. Is it all coming back now? Okay, so an ionic compound is a compound made by the electrostatic attraction between a cation, which is a positively charged ion, and an anion, which is a negatively charged ion. In other words, you have a transfer of electrons. Something has lost electrons to make a cation, and something has gained electrons to make an anion. All right? So ionic compounds are those compounds between cations and anions, plus charge, minus charge. Covalent compounds are compounds made when species share electrons. Okay, when species share electrons. You probably have also heard of these referred to as molecular compounds as well. Okay, molecular compounds as well as covalent compounds. Covalent. Valent shell electrons, comparing, sharing, okay, combining, all right. So covalent compounds are compounds made when species share electrons. I don't know, but you probably have been introduced to the terminology of polar covalent and nonpolar covalent. Polar covalent compounds are where the electrons are shared unequally, and nonpolar covalent compounds are when the electrons are shared equally, nonpolar. Okay. All right. Now, what we're going to do is we're going to start with ionic compounds and learn how to name those, because there's a couple of different types that we need to look at. They're still ionic compounds, and then we'll look at the covalent compounds. All right? So let's look at ionic compounds. Okay, so ionic compounds, cation and anion. That's the key. What typically forms a cation? Metal or nonmetal?
Metal.
Okay, metals. All right, so if we have a metal cation combining with what typically forms an anion? Nonmetal.